welcome back. Our first video, we pixelated our image. So in this video, we're going to what's called quantize our image. Now, what quantizing an image is basically we're going to be giving it a set number of colors, and we're going to take every pixel in the image, and we're going to make it one of those colors. It's going to be a little more complicated than pixelating, but it's really not so bad. I'm going to try to explain everything that I can. Don't have a ton of time to do that, so let's just get started. So func quantize. We're going to do an image.image like we did right above, and then we'll do the number of colors, which is going to be an int, and then we'll return our image as well. Now, what we're going to actually need is a way of representing a pixel as a struct. So we'll actually create a pixel struct, and we're going to give it RGBA properties, and they're going to be uint32s. So, like before, we're going to take our bounds. They're going to be equal to image bounds. Then we're going to take an array. We're going to make a new array of pixels. We're going to fill it, and then we're going to make it dx times bounds.dy. And what this is doing is taking every pixel in our image and making an array of those pixels. So we've got a default array here. We're going to loop over every pixel in our image and append it to this array. So we can do that by doing a nice little for loop, bounds min y less than bounds max y plus for x inside of bounds min x is less than bounds max x plus plus. Great. Now we can take our RGBA values and at x and y dot RGBA. Now, what this does is it's going to get we're looping over every pixel in our image, and we are. Do you not see my cursor? That's stupid. We're taking. I just realized that you can't see my cursor, and that's really frustrating. We are taking every pixel in our image, and we are going to do something with that. So we're going to append it to our pixels array. So we're taking our RGBA value of the pixel at our x and y coordinate, and then inside here we can append it like this. Just like that. So now our pixels array something doesn't look right. There we go. Our pixels array is going to be full of pixels. What is it? What's it screaming at? So why is it mad at me? Okay, we got a pixels array. Okay, so now what we're going to be doing is what's called a k-means clustering. So what this basically means is we're going to take the number of colors we're giving it. So say 8 colors. We're going to take 8 colors. We're going to take our image and basically average down every single color from every pixel in our image, and we're going to get our 8 colors based on the pixels in our image already. So we're not taking 8 colors that we're just deciding on. We're going to, we're not giving them hex values. And we could do that maybe another time. That'd be kind of cool. We're going to take the average 8 colors from this image, and we're going to apply it to the rest of the image. And so by what we're going to do first is we're going to take what are called centroids. We're going to take the average 8 colors, our centroids, and we're going to find the clusters from that and then distribute them out. We're going to create a new image based on that. So let's just, maybe it'll make more sense when I'm coding it. So we're going to take what are called centroids, and we're going to make a, so say we have 8 colors, we're going to have 8 centroids. So for I is less than equal to 0, or is equal to 0, I is less than the number of colors, and I is less than the length of pixels. And what that basically does is say, hey, if there's more colors than pixels in our image, then go ahead and clamp it down to the size of the size of the pixels in our image. Okay, so inside of here we can do centroids at I is going to be equal to pixels at I times the length of our pixels divided by the number of colors. Okay, now we've got our initial centroids array. Now what we're going to do is we're going to iterate 5 times, basically. And so what that means is we're going to gather the average 5 times. We can do it as many times as we want. 5 seems to be a pretty good just baseline. And I haven't really messed with anything besides that. It's been working, so I'm going to leave it. Clusters. We're going to make a new array called clusters, which is going to be an array of pixels. Array of arrays of pixels. Range clusters, and it's going to be clusters I is going to be equal to a new empty pixel. So now we've got our clusters declared. Okay, so now what we're going to do is we're going to assign the pixels to the nearest centroid. Okay? So we're going to go over our pixels, and we're going to assign it a centroid, basically. And to do that, we're going to do a loop over our pixels array. And we can do that by doing range pixels. And then we're going to take the minimum dist uint64, and we're basically just saying, hey, as large of a value you can make, start there. 0, and then we're going to loop over our centroid array. All right, so now we actually need to make a new method really quick. And what this method is going to do is take 2 pixels, and then it's going to take the difference between the R values, the difference between the G values, the difference between the B and the A, and then we're going to create a new uint64 based on that. So func qdist is going to be p1, p2 is going to be of type pixel, and then we're going to return a uint64. Okay. Wow. All right. And then so our dr is going to be equal to uint64. I'm sorry, int64 of p1.r minus uint64 of 2.r, and then we'll do that for our G, B, and A values as well. So G, B, A values. Okay. Then we will return a new uint64, dr times dr plus dg times dg plus db times db plus da times da. We've got a new, oh, something doesn't look right. What am I seeing here? Ah, that's what it is. Uints. Okay. We've got a new uint64 based on our RGBA values of the difference between our pixels in our pixel array and our centroids. It's basically saying, of these 8 colors in your centroids, assign a pixel, replace the pixel in our pixels array with one of these colors. That's essentially what it's doing. All right, so we can take our dist is going to be equal to our new distribution of P and C, our pixel and our centroid. If the dist is greater or is less than the minimum dist, then we can do min dist equals to dist, and then our cluster ID is going to be equal to the ID we're on. Now, outside of this for loop, we can do clusters at cluster ID to append clusters cluster ID pixel. All right. So now we're going to basically assign the clusters at the cluster ID one of these pixels. Great. Now what we can do is, wait, I need to still be inside of the iteration. We need to update our centroids. Yay. So to do that, we can loop over our clusters. For I in cluster equal to range clusters. If the length of the cluster is 0, then we need to continue. Continue. Wow, I can't spell. We're not going to talk about that. Okay, so now we can do RGBA, uint64. Then we can loop over our clusters, and we're going to add up the RGBA values of the cluster. So for pixel inside the range of cluster, r plus equals uint64 p dot r. We'll do GBA. Same thing here, GBA. Great. Now we have our added up values. Then we're going to take the count of our uint64 length of cluster. So we're going to take the count and we're going to average out these values, these RGBA values, and apply them to our centroids array. Be equal to a new pixel, and that's going to be r uint32 r divided by count, and then we'll do that for each of these. Then we'll do like this. Bam. All right, cool. So our centroids have now been updated. Now what we can finally do is create a new image with our quantized colors. Awesome. So to do that, we'll do a result. It's going to be equal to an image like we did below, an image dot new RGBA. We did this in our pixels method. Return result. So that stops screaming at us. Now we can do this same right here. Hello, centroids. Can't spell. We can do a double loop again here. And now what we're going to do is kind of like we did in our pixel method as well. We're going to take the RGBA pixel at our X and Y coordinates, and we're going to take this dist between them. We're going to take the nearest pixel and we're going to apply it to that pixel. Okay. RGBA image at X and Y dot RGBA. Our pixel is going to be RGBA, our current pixel that we're on. We'll take our minimum dist uint64 like we did up here. Let's just do that again. Like that. Then we can do var nearest pixel for centroid, for each of the centroids. If the dist is sq dist of p and c again, dist is going to be less than min dist, then we will min dist equals dist. Nearest is equal to c. The nearest is going to be the centroid. Okay. Finally, after all that, we can set color RGBA. Okay. So now we're going to be setting our pixel to be the uint8 nearest R8. Drop it down to 8, and then we'll do BGA. Ooh. That's not what I wanted. There we go. There we go. And I think that's it. Okay, I think that sets the image the way we want it, based on our centroid. So what do we got here that's being mad? SQ dist is not being used. That's not true. It is not unused, you liar. I don't know what it's screaming about. It is being used. What are we doing? Oh, I don't think it is being used because quantize is not being used yet because we have not called it yet. So we'll do our quantized image. Number of colors. Color. Oh, we haven't created a number of colors yet, so we can do num color method or number of color properties, and we'll start with 8. Then our quantized image is going to be passed to our pixelated image. So we're going to quantize first, pixelate second. And I think that's it. I think we can call it now. Let's try it again. So if you remember from last time, we had, here's our regular image. Here's our pixelated image. Let's call this and see if it updates. There we go. And you can see, did you see that it dropped it down to 8 colors? So let's drop it to something we can see more recognizable. Let's do 4 colors. And we can actually count these up, I'm pretty sure. Great. So we got 1, 2, 3, and 4. So we got 4 colors here. You can't see my cursor, which is really silly. If we really need to see the difference, we can just do 2 colors, and it will drop it down to 1 of 2 colors. That looks really silly. Cool, though. Cool. And we can do pixelated image with colors. There we go. All right. And that's it. What we've done now is we have pixelated our image, we have quantized our image, and that's the project. This code should be up on GitHub. I will post a link down below if you want to follow me on GitHub or X or YouTube here. Please like, subscribe, follow along. I'm going to be doing a lot more of these kind of videos. I really enjoy them. Learning this kind of stuff is really fun. And yeah, this has been great. God bless.